in your paper. And so I already graded the assignment, but not the test. So hopefully I can return the test on Monday next week. Okay. Regarding for the test, I just feel that those who really do the sample test did really well on the test. If you guys did not do the sample test, then it was tough. I can tell. Okay. And I know, I realize that. You know, when I graded, I know right away who did not do the sample test, who did do the sample test. So the sample test is really helpful, guys. I don't know if you know it, like, actually it's not much different. I just changed the number. The concept is the same, everything the same. Yeah, we don't do anything harder than the standard one. On the test, especially on the test, I don't give you anything really hard now. Just that the standard, something similar to what we learned in class, similar to the example, to the homework. Okay, and I have to say that some students like very disorganized. Okay, you guys just a little bit here, a little bit there, and you know, I look at that, it's very hard for me to grade. So when you receive a test, make sure you read my my comments. I usually put my comment on the test. Sometimes I said, oh, okay, don't treat it as scratch paper. Because some students, I don't know if it's from this class or from the other class, because I have several classes. You treat the test as if it was a scratch paper, and this is not a scratch paper. So at this moment, I know we already finished the first test. Some of you got a good grade, some of you did not have a good grade. Don't panic, okay? Because you still have more opportunity, and even though you did not do well on the first test, if you show me that on the second test or on the third test, you really try and you really improve your grade, then everything will be okay. I just go ahead and ignore it. Okay, that's what I do to help you guys. Okay, or maybe you show me something, majority show me something, then maybe on the final I let you guys talk to each other. Or maybe on the final I'm going to split into two parts, and you know, one part you take home. But you gotta show me something, okay? A couple students, kind of strange to me, that a couple students, they come to class on the first day, and since then, they never show up until the test day. So it's kind of really strange, okay? So I want you to come to class more often. Even you guys come to class, it's very hard for you to understand the material sometimes. Sometimes, yes. So let alone not go to class. So I want you to come to class very often. I know it's not a part of the attendance. Come on, this is your responsibility. It's your kind of class, right? To really understand the material, you have to. Okay. We have the assignment number 4, I believe so. Is that number 3? Number 3. Okay. It's not due this week. I believe it's due Monday next week. So please read the syllabus. Please read the syllabus. Okay. I made this beautiful schedule for you guys, and I know some of you just did not read it. Okay. Just follow the schedule. If you follow the schedule, you should be okay. Okay. Let me see. I have some paper over here. I just want to return this. Jenny. All right. Jacob. Okay, see that? Some students didn't know when they were coming to class after the test. I know. Okay. So very good. Julio. That's some part of the extra. It's not here. Okay. So if I give you extra credit, try to do extra credit. Okay? Because that is the offer I give you guys. I don't have to do it. It's not mandatory for me to do it, but it's my offer. here. Bottom. So again, I really recommend you guys, if you guys still have trouble with basic one, because when I grade the paper, I see that several of you still not able to factor trinomial. That concept back in the day, that concept you learned in intermediate algebra and you don't know how to factor trinomial, I mean, you have to come see me, okay? Or at least you come see math tutor in the math center, okay? So it's not here. It's not here. All right, Cian O'Donnell never show up. It's weird. Okay, Blake Naziger. Okay, you got something. Okay, still not here. Two. Here. Okay. Yeah. So here. Here. I mean, you do bad on the test, on the assignment, that's fine, but you know, it's not tolerated if you don't go to class. I have no mercy if you still don't go to class. Okay? You guys go to class, you guys probably get an F. And at the beginning of the semester I say, oh man, I don't want to give you F, you know, this is the lowest sometimes to me. But if you don't go to class, I don't know how I'm going to help you. Okay, still not here. Again, good job. Okay. Good job. Alright, so you have any questions, let me know. Again, I report the solution. Yes. Oh, it is. I didn't see that. Okay, you what?
You can mine.
Oh, let me see. You should have it, right?
Is it the one with all like the
I think I already read.
assignment 2?
Yeah, right here, you got it, right here, yeah. Alright. If you have any question related to the solution of the assignment, let me know. Again, I already post the solution online, guys, on YouTube. Go ahead and watch it. Not a lot of you watch it. You know, I post a beautiful video, you know, careful writing, you know. But not a lot of you really watch it. Yes. Yes, that's the whole channel. You go over there. There's everything everything in that channel. For the solution of the test, I don't have time to go through the solution, but I will post the solution online as a PDF file for you. Okay, for you to check. And please take a look at that. If you guys have any questions, come to see me. Let me know right when you don't understand anything in the solution, because sometimes I have human error too, you know. Let me know, okay? When I go fast, I have some careless mistake too. It's understandable, you know. Really, that's why, you know, on the test, on the assignment, if you guys have like careless mistake, I might ignore it. But if you guys like treat it as it's a scratch paper, it means that you guys don't show me good learning behavior. So don't treat it as a scratch paper, okay? Even when I do the lecture, you remember when you do the lecture, I said, okay, this example 1, and I put solution, answer, I underline it. I write carefully. We beautify math, right? Math is beauty. So you guys have to write carefully, because if you don't write carefully, I don't understand you. I don't know how to grade it. It's very hard for me to grade. Okay, so try to be organized, write everything in order. Okay, and improve yourself. Show me good learning behavior, a positive learning behavior, so that at the end of the semester, I can have some mercy for you. Okay. So far, everything's good. Don't panic, because again, this is just the first test. Okay, you guys are gonna get better. This is just an assignment. Hopefully, you guys are gonna get better. But I always recommend you guys get together in group. Okay, help each other. Get help from the math center, because there's a lot of you who got a good granted. Okay, I have to say that. Okay, some of you did not. Get together, help each other. Get help from me, from the math center, from Valencia. Then I'm sure everything will be alright. Okay? Any questions? Okay. Alright, so let's continue with our linear equation. So far we learned two methods, two forms of write or construct a linear equation algebraically. The first method is we use y equal to mx plus b. The second method is we use standard form ax plus by plus c, and we learn how to convert back and forth. This is one of the problem I give you on the test, and most of you got it right. I'm very happy. Okay. Another way of writing a linear equation, we use the point slope one, and this point slope formula, majority of you like it. Okay, because it's easier to use, and it's as long as you get the point slope, you can convert back to the slope intercept form in order to get the b. So let's continue with our linear equation, linear function. Linear function. Okay, so we already talked about first form, second form. So this is the third one. This is the point slope one. Point slope formula. Point slope form. Okay. And in order to use point slope form, you need to know two things. First of all, you need to know a point, given a point. Okay. If you don't know the point, then you cannot write an equation using point slope. Okay. So I say the point over here will be point x1, comma y1. And we also need a slope, even a slope, m. Okay. As long as you have these two information, you can write the linear equation in a point slope form. And point slope form is y minus y1 equal to m times x minus x1. Okay. It looks very familiar, right? You guys already learned this in high school course. Okay. And the good thing about point slope, because we can convert back to slope intercept form. So from this, I can convert to slope intercept form. How we do that? We just use some basic algebraic manipulation, add, subtracting, sometimes with distribution. Then you should get the slope intercept form. The reason we want to get the slope intercept form, because as long as we get the slope intercept form, we can find the b value. If you look at this form, the point slope form, it's very hard for you to get the b value. Let's take a look at the example. Write linear equation that goes through 2 points. Okay. The first point I call point A. Okay, there's the coordinate is 2, 3, and another point is 4, 7, for example. So I give you the point. That's good. Because it looks like one of the conditions is satisfied already. We already got a point. And it doesn't matter which point you want to choose. You know, usually I pick the smaller one, so I pick 2, 3. Okay? But you need the slope. Do you think that we can find slope? Yes. Yes. So go ahead and do it. So first of all, I just go ahead and write out a formula. Okay? Because I already know one of the point, so I just plug it into 3 into y1 and x1. So y1 will be 3, m x minus x1 will be 2. Alright, now I'm going to find the slope. Okay, what is the slope formula?
y2 minus y1
y2 minus y1 over x2 minus x1. Look very simple, right? However, I don't know if it's on the test or on the assignment. There's some student, you guys just swap my formula. Like the bottom become the top become the bottom. So you put x2 minus x1 on the top. You know how to do it? When you have careless mistake, everything gets wrong. Everything becomes useless. Yeah, I did use a couple points, you know, as partial credit, but you just swap my formula. So make sure when you learn carefully, okay? So now plug in. You 4, 2, 2. Plug in, go ahead with subtraction. Divide by 2, give you 2. Now I have the slope. I got the whole equation. Y equals 3, y minus 3, 2, x minus 2. What side is? Everybody? Alright. So this is a point slope form. It's a point slope form. Now I want to convert this to a slope intercept form. What do you think? What are we going to do? Distribute it. Yeah. Because we have parentheses. We need to isolate the point. The slope intercept form is y equal to mx plus b. We need to isolate the y. Okay, with y over here already, that's good, but we're getting stuck with number 3. However, we need to distribute this first. So I'll give you what? 2x minus 4. And what next?
So y equals to x minus 1.
Yeah, because you add both sides by 3. Yeah. There you go. So I see I can convert this slope to slope intercept form easily. Okay, and right now I can define a b value. The b value is -1. The reason I want to define a b value because it's for graphing, guys. The b value is just a part of the y-intercept point. The y-intercept point is the intersection point between the line and the y-axis. If you know this, I just pick up one of the point, and you know the x-intercept point, you connect and give you the graph. That is one of the question on the test also. And in the previous lecture, I also give you some examples related to that. Okay, so that is the point slope form. And now you learn how to construct a linear equation using these 3 forms. You know how to graph it. Okay, we have certain method of graphing. You use x, y intercept point. You use rise over run method. Okay, but sometimes you want to construct a new linear equation based on another equation, based on another linear equation. Okay, when I say based on another linear equation, it means it's based on the slope of the other linear equation, or based on the y-intercept of the other linear equation. So we want to compare. We want to compare if the slope will be the same or the slope will be different. What happens if the slope will be the same, and what happens if the slope is different? Okay, so let's consider the first part of our lecture today. I want to talk about parallel lines. Okay. I want to ask you a question. I don't know if you remember. I know that most of the time, I think all of you already learned how to solve system of linear equation, right? When you solve a system of linear equation, anyone can tell me what's the solution of the system means? Graphically, what does it mean graphically? Okay, solution is okay. That's slow. Okay, not quite. Good try.
Like what the two lines are, like for each, if it's parallel, perpendicular, or something.
Okay, when you solve the system of linear equation, right?
Mm-hmm.
And your answer is something with x and y, right? What's that? A secant line. Okay. Not really. Okay. So when you solve the system of linear equation, the solution is actually the intersection point between two lines. The solution is the intersection point between two lines. So if the two lines parallel to each other, we don't have solution for that system. Okay? If two lines are overlapping each other, we have infinite many solutions. So the solution of the system of equation is the intersection point between two lines. Okay? So in this case, I'm talking about parallel lines. It means that that system doesn't have any solution, because when it parallel to each other, two lines never cut each other, right? Never cut it. You know, especially in geometry, when you draw two parallel lines, never cut it. I'm not talking about the modern geometry, because sometimes in space, you know, two lines might cut each other. Two lines parallelly, it cut each other sometimes. Okay? But I'm talking about the 2D, two-dimensional geometry. When you draw a first line and you draw a parallel line to the first line, it never cut each other. Okay? And what happens when it parallel to it? What happens to the slope? Okay? So let's consider the first equation is this: y1 equal to m1, y1 equal to m1, x1 plus b1. Okay. And the second equation is y2 equal to m2, x2 plus b2. Actually, if I put a curve, the curve bracket, it gives you the system. I know you remember the system, how to solve the system. Anyone remember how to solve the system of linear equation? Anyone? That's the intermediate algebra.
Is it the one when you subtract something?
Something. Right. There are two methods. Actually, there are three methods. First method is graphing. The second method is
substitution.
Yeah, substitution and
elimination.
Elimination. But I'm not talking about how to solve the system over here. Yeah, but it's good for you to make a quick refresh. So there are two methods. Alright. So for these two parallel lines here, I say that L1, I call this line is L1, and I call this line is L2. Okay? And I say that L1 is parallel to L2. This means parallel symbol right here. If it parallel to each other, okay, if two lines parallel to each other, the slope the same. So m1 equal to m2. This information is very important, because we're going to use this information to construct a linear equation algebraically. So if I draw two lines, something is going to be like this. If we have the L1 over here, and I may have L2 over here. They're parallel to each other. Alright. So let's see how we're going to construct linear equation using this information. Let's take a look at the example. I want to write a linear equation that is parallel to line y equal to 2 over 3x plus 1. Okay. And goes through point 2, 3 for example. Okay. So the equation we want to write, first of all, the information we get out of the question is that equation parallel to y equal to 2x, 2 over 3x plus 1. Another information that the equation we want to write goes through the point 2 over 3. It means that the point 2 over 3 belongs to that line. The point 2 comma 3 is on the line we want to write. Alright, so how are we going to write? Okay, let's see if we can use point slope form. We've been learning point slope. So let's see if we can use that. So go ahead and write out the formula. You can use any other form too if you want to. Okay, but point slope, a lot of students really like it. So I use point slope. It's much easier than the slope intercept. Okay. Do you think that we have the point to plug into the x, y1 and x1? Yes. Where? 2 and 3. Because they give you that. They say it goes through point. Just plug it. So I'm going to plug in. Alright. Now our job, the same slope. Yeah, because our job is right now to find m. But the information here, the information I give you, is say what? It says parallel to this. It says parallel to this. Oh my god, this is...
Wouldn't it be negative 2 over 3? Or no?
Oh, no, it's not negative because it's a parallel. It is exactly the same. So the slope, the new slope, will be the same as this slope. Okay? So that's why the m over here, I can replace that with 2 over 3 x minus 2. I just got this from the math department. We couldn't use this. That's why I hate whiteboard, guys. You know, I'm very traditional guy, I use like chalkboard. But they don't have chalkboard in Valencia anymore. In UCL, yes. Okay, so this is the point slope. We already got the point slope. Okay? And you don't have to convert it to slope intercept for all this. I want you to do that. So you can just leave it like this if you want to. Okay? Any question for the parallel case? Good? Alright. Next, we want to talk about perpendicular. Lines. What happens if our two lines, are perpendicular to each other? What happens to their slope? Again, I have two lines. I call that L1. Y1 equal to M1 x1 plus B1. L2 equal to Y2 M2 x2 plus B2. And I have L1 perpendicular to, this means perpendicular, simple, L2. When you go higher, especially when, anyone do computer science here? especially computer science or no? Okay, okay. Because when you do computer science later on in computer science, this symbol we call that orthogonality. Okay, it's not perpendicularity anymore, but we call it orthogonality. Okay, so if the first line perpendicular to the second line, the slope is not the same anymore. No, of course not. But we know this. If those two lines perpendicular to each other, we know the product of the slope of these two lines equal to -1. The product of the slope equal to -1. Usually in high school, your teacher teach you that in order to find the slope, you just flip it and you put the minus sign in the front. You know, back in the day, you know, in high school, if two lines perpendicular to each other, you just flip the slope and you put negative sign in front. But actually, it's come from this, the product. Alright, so go ahead. I want you to memorize this too. Okay, and if the two lines perpendicular, we can have something like this. So I have the first line, and the second line look like this. And we have a 90-degree here. Now let's take a look at the example. I want to write linear equation. Okay. That is perpendicular to line y equal to -1/2x minus 1. Okay, comma, and goes to -2, comma 5. Okay. How we do this? Okay. So we have a point, which is good, because we don't want to use the slope or the point slope form. So this is point slope form. Go ahead, write it down. Okay, that's the point slope form because we are learning point slope form right now. And I have a point already. So if I have a point already, I just go ahead and plug them in. Okay. Let's go ahead and plug them in. Job right now is to find A. The only information we never touched, this is the perpendicularity right there. Okay, so in order to find M, and every time you see the perpendicularity case, okay, this is what you do. Actually, this has come from this formula. Okay, so in order to find M, this is what you do. You make this reciprocal between the top and the bottom, okay? And you put the minus sign in the front. So go ahead and make it reciprocal. What do it give you?
2.
-2, right? Because we still have negative. But we put the negative sign in the front, so it gives you 2. Okay, so be careful. If I have over here is 1/2, it will become -2 as this new slope. Okay? So you make a reciprocal and put the negative sign in the front. It's come from this. Actually, it come from this. I'm going to show you why. I call the slope I want to find is m2, right? And the slope is given is -1/2. So it is m2 equal to -1. So this is m2 right here. Okay, so in order to find m2, what do you do?
-1 over -1/2 minus half.
Oh, this is multiplication.
Yeah, m2 equals -1 over minus half. So equals -1 times 2 times -2.
Time, yeah. Time minus
2.
-1. Time -2. Like that?
Yeah.
Okay, right? Because everybody agree with her, right? So look at that. So she multiply both sides by -2. She multiply both sides by -2. And you see that? It cancels out right here. So negative times negative is positive. 2 divided by 2 is 1. Cancel out. So she multiply by -2 here. So the new slope will be 2. Because -1 times -2 will be 2. So usually you don't have to do this step. You just need to flip it over and put the negative sign in front. That's much easier. But I want to use this graph because I want to show you that it comes from this form. Okay. So I got a new slope and I got the final equation. Okay. This is intermediate algebra. In intermediate algebra, you guys had a chance to have a class with me on intermediate algebra. I already talked about this. Okay. And I gave the student a bunch of homework to do. A lot. You had class with me, still. So I mean, again, you guys have to memorize it. There's a lot of things you guys have to memorize. This memorization is a part of life. What? Now, in the next 2 days we have what? We have Valentine's Day, right? Anyone has girlfriend, boyfriend over here? And come on, you're not allowed to forget. No, they kill you, man. They kill you. No, you gotta buy something. No, you know. I stopped buying the gift to my wife after I married her because she's too far away. So I want to send her something, but I mean it's pretty far, so I couldn't do that. But I told her, okay, as long as she comes over here, then I'll buy her something on Valentine's. Oh, you have boyfriend, girlfriend, right? And so you have to know her birthday. You need to remember your boyfriend's birthday. Come on, right? So you see that memorization is a part of life. It's not just in school. There's a lot of things you have to memorize. When you guys grow up, you guys have family, you have kids. Come on. How many bills you have a day, a month? Electric, water, a bunch of bills, internet, so on and so on. And each account has a password. And you have email password, and you have school password, and you have work, at work password. You have electric bill password. You have to memorize. Well, otherwise you have to write it down. At least, because you want to lose it. Yesterday I lost my password. Amazon. I called them. Oh my God! You know how much time it takes? Like an hour. You don't want to lose. No, you have to memorize it. Or write down some like notebook or somewhere, guys. That's the hard part. You know, it's not easy. It's the same thing over here. You have to memorize. You have to keep moving. You improve yourself. I know there's a lot of information you get into your brain at the same time. Yes, understandable. Yes. I experienced that myself. When I'm in graduate school, there are 1,000 formulas. That whole book. when you do the thesis, it's like this much. That much paper you have to write. Yes.
You have to write a thesis for math majors?
Yeah. Of course. You have to do
like
research.
Theory?
Yeah. You have to do research. That depends on what branch of mathematics you love. You do research on that one. You do research on how to solve a certain problem that never been solved before. If you can solve it, you got a few medal, maybe, you know. But you see, there's a lot of things you have to memorize. In order to write a bunch of people like that, just think about how much formula you have to memorize. Because if you don't memorize stuff, every time you turn the page, you cannot do the problem. Especially on the text, right? I did not give you a cheat sheet. I shouldn't say that on camera. We will do cheat sheet. This is not high school. So please take time to memorize whatever we learn. Okay, whatever we learn, please. Okay, so that is perpendicular lines. That is for parallel lines, and so basically we finished a linear equation. But I want to talk about the application of linear equation also, because linear equation is very useful in real life. To be honest, it is very useful, especially when you do accounting or if you've majored in finance. So on the third part, I want to talk about application. And of course, I just want to talk about one aspect of the application. There's a lot of application, real-world application related to linear equation. And one of the application of linear function, linear equation, is we use linear equation to write a model, to model relationship between the cost function and the revenue, as well as the relation between the profit function, the revenue function, and the cost function. Okay, so linear equation function is used to model cost function. I call C of x. So this is cost function. Revenue function. This is revenue function, and it's also used to model the profit function. This is profit function. Okay. So because cost function, revenue function, and profit function are linear function, and of course it must be in the form y equal to mx plus b. Okay, so c of x is a cost function, is equal to mx plus b, and we need to understand what m in this case. Okay. So m we call that. This is the cost per item, per one item. Okay. And B, this is a fixed cost. If you guys, I don't know if you guys ever make a long distance call. You want to call someone in Europe, right? And the company said on the first minute, during the first minute, they charge about maybe like $2-3 for the first minute. Then afterward, it will be maybe 20 pennies more for each minute. So the first, the fixed cost will be $2 in the first 1 minute. Okay. Then later on we have the cost per one item. Okay. It means for every minute they charge differently. Okay. They probably charge like 20 cents or 15 cents, depends on each company. Okay. And the revenue function equal to P times. Now what does it mean by P? P is, let me see, P is the price per item. Okay. And X is the number of items. How about the profit? The profit, in order to find profit, you take revenue, you minus the cost. Alright, so profit equal to revenue minus cost. And it totally makes sense, you know, because what if you want to open a company, okay, and you say that the cost to open a company, you have to buy a lot of things, right? That will be represented with C function. Okay, revenue is the amount of money you make, the gross income you make a month. So that could be represented with revenue, and the real profit, the money, the amount of money you put into your pocket after you pay rent, you pay the labor, you pay for the manufacturing. Okay, you do subtraction and the amount of money you really receive. Okay. All right, let's take a look at the example. Let's see. Let me write over here. Okay. Example. Let me see. I can just project this on the. I have to write this. This is much faster. But I think you guys have to write it right away. But let me see. Okay. On. There you go. Just warm it up. I'm not really good at technology. I know why. You know, that's why I said last time you guys give me. I use the calculator, the TI-84, 85, but you know, I'm not like really an expert in that. I know just the things I need to know. That calculator is very useful. It can do a lot of things with the crazy mathematics, but we don't have to be honest. Okay. So all the technologies, I'm just okay, not really good at it. Okay, let me see. I'm going to connect to camera. There you go. Oh my God. All right. Okay, so let's take a look at this one right here. I think I'm going to erase. Okay, look at example number 6. I'm going to erase this. Okay, so you can see easily. We can work over here together. Can you guys see that? It's good enough? Can you? Let's read this together. And some of our show, okay, a vendor sells lemonade for $2 per cup. The cost to rent the booth is $120. So it looks like one of the examples I just told you, right? I just said. Furthermore, the vendor knows that the lemon, sugar, and cups collectively cost $1.5 for each cup of lemonade produced. Okay. And we want to write linear cost function. Okay. That to produce X cup of lemonade. So in order to write the cost function, of course we're going to use c of x equal to mx plus b. We have to do that. We have to use that. So let's start together. So this is the cost function. Okay, this is the formula. Do you think that we know m? M is what? M is the cost per item.
Yes.
What is the cost per item?
0.50.
50 cents.
50 cents. Okay. Cost. Okay. Okay, that's 50 cents. So I know m is 50 cents, which is 0.5. So c of x equal to 0.5x. And b is what? B is the fixed cost, initial cost. 120. Yes. So b is 120 because that's the cost you have to pay for rent. That's the cost you have to pay. So I have the first function, cost function. Okay. Any questions? So look like everything is there already give you. You just need to read the word and really understand the word. Okay? Really understand the word. Alright, how about the revenue function? Let's do the revenue function. Okay, revenue function equal to what? Revenue function equal to p times x.
$2.
Okay, what is p? P is what?
Price per item.
Mm-hmm.
$2.
To be $2. So it will be 2x only. Because right now we don't know the number of items. So the number of items we call that x. Okay. So the second function we have C. Profit. Oh, easy. Profit function equal to what? Profit function equal to revenue minus cost. Okay. Be equal to what? 2x. Revenue is 2x minus 0.5x plus 120. Okay, so if I distribute the minus in, I have what? I have 2x minus 0.5, 1.5x minus 120. So that's the profit function. The profit function is help you to calculate your profit. You know, if you sell a certain number of items, okay, it's very useful. This model is very helpful in real life. Okay. All right. Now for part D, I want to find the profit. You see that? I want to find the profit if the vendor makes 50 cups of lemonade. So how are you gonna do that?
So P of 50.
P 50.
P of 50.
P of 50. Very good. So it means X is 50.
Yes.
Because we want to sell like 50 cups, right? So I just go ahead and plug them in. 1.5 times 50 minus 120. Please give me the answer. What do I give you?
Minus 45.
Negative?
Yeah.
That's what I.
Yeah, it is. Okay, what does it mean?
He's losing.
They're losing. They don't make money. They're losing. They lost $45. How come negative? That's what it means. They don't make money. Okay, they lose it. Okay? Usually on the test, I don't give you something like that. You know? But probably in the assignment, you will see it. Okay. Part E. Okay, how much product will we make for the producer? Okay, 120 cup, you do the same thing. 128, I'm sorry, P128. Let's see this make money out of this or not. Okay, 1.5 times 128. Give you what?
72.
$72. Okay, $72. So if you sell 128 cups of lemonade, you make $72. Profit, okay? Not the revenue, profit. I mean the amount of money you put into your pocket. Okay? F. Determine the break-even point. Anyone really understand this term?
Yeah.
Yes.
What is break-even?
Equals 0.
No, it's the same.
So yeah, it costs the,
The
there's no
amount you
profit.
spend
Their profit.
equals-
Profit.
The amount that you spent equals the amount that you got back, basically. To break
Yeah, that's what it means. It means that at that point, you start making money. Okay? So, this break-even, you set up the profit, which is what? Profit is what? That function, right? One profit equal to?
0.
No, not 0. Profit equal to the, what's that one? The profit equal to the revenue, I'm sorry, the revenue. The revenue equal to the cost. Because at this point, you guys start making money. Okay? Before this point, we don't make money. Okay? So revenue equal cost. Revenue equal cost. Revenue is 2x, right? Revenues, the function is 2x. Equal to, cost is what? 0.5x plus 120. Alright, go ahead and solve x for me, please.
A.
Okay. It means what?
P of A equals 0.
Yeah, it means that after you sell 80 laminate, cup of laminates, then you start making money. That's what it means. Yeah, there's another way to do this. You put a profit equal to 0. Okay, you can do that too. Okay, that's another way. Profit function equals 0. The same thing because profit equal to revenues minus 4. Same thing. Okay. So this also gives you x equal to a. So you set this equal to 0. 1.5x minus minus 120, and you solve for x, and of course it's you x equal to a. Any question? Any question? I'm going to turn that off. So right now we learn most of the concept here related to linear function. And linear function is one of the very important function in college algebra. Other than linear function, in this course we also learn 6 more basic functions. So today we want to go over those 6 more functions. We want to investigate the domain and range of those 6 functions, and we compare with the to the linear function. We see that if we have the same domain or range or not. Okay. So on the 1, 2, 3, 4 part. I want to talk about basic functions. Hopefully I have enough time for all of this. So the first function we've been learning, this is linear function. Okay, and the linear function, we have a form f of x equal to ax plus b. Okay, a, b could be any number. And if b equal to 0, then it becomes what? F of x equal to
mx.
a of x.
A of x, sorry.
Because b turned out to be 0. I throw away b. Okay. And this function over here, the graph, the line represented by this function, is always go through the origin. So the line going through origin. Okay. So if you see the function, the linear function in the form f of x equal to ax, for example, like 2x, negative 5x, 2 over 3x, without a b at the end, you know right away when you graph it, it always goes through the origin. The line goes through the origin. Okay? So it's always look like this. Alright, it goes through the origin. It could be slanted upward. It could be slanted downward. It depends on the value of a. If a is positive, okay, so it's upward. So if a is negative, it's downward. So the graph I just draw here is upward. Okay. Alright. Now let's investigate the domain and range. Anyone remember the definition of domain? Oh, on the test. Oh yeah, on the test. Anyone got that question on the test? Okay, can you tell me what is domain is?
All inputs that make the function defined.
Yes. So all the value that make the function defined. It means that. It means what? It means the value, all the value on the x-axis. Okay, when you pick any point on the x-axis, when you draw the vertical line, it gives you a point on the y-axis. Oh, on the curve on the line. So if you pick a point here, it gives you the point on the line. So we have a bunch of value on the left here and a bunch of value on the right, right? So the domain will be what? What do you think? Infinity. So we go from negative infinity to positive. Because remember, domain, you always look from left to right. Always look from left to right. Okay? So there's a lot of point here. A lot of point here. How about range? Also the same. So look, you pick any point on the y-axis and you draw a horizontal line. You see that? It's always have a point on the line. Okay? So it's always defined. No matter what value of x, it's always defined. That's why the value of x will be everything from negative infinity to positive infinity. And you apply the same way if we have the linear function in the form f(x) equal to ax plus b. Okay? You look at from left to right for the range, for the domain, and for the range, you look from bottom up, not top down. Okay? From the bottom to the top, not from the top to the bottom. Okay? All right. So that's our first function. The second function I want to talk about is called square function. Later on in the next few chapters, the square function we call the quadratic function, because this is the second degree form. Okay? So this is the square function. We have another name for that. It's called polynomial, second degree polynomial later on. Okay, but I don't want to mention that terminology right now much. Okay, so I just call it square function because it's square. And so, okay. In the next few chapters we talk about quadratic, and it's in the form ax squared plus bx plus c. It's just the general form of the square function. Okay, so it's just the basic one. Okay. All right. Let's go ahead and graph this. Let's see what happened. Because as long as I graph the curve, I can define the domain and range. What value you want me to plug them in? 3?
0.
0, 0. Okay. 0 give you what?
0.
0. What else?
1 gives you 1.
1 gives you 1.
2 gives you 4.
2 gives you 4.
3
gives you 9, right? I think that's good enough. I think it's good enough. Alright, so look like let's go to this one, right? Okay, 1, 1, 1, 1, right here. How about negative? Negative 1 give you what?
1.
1. Negative 2 give you?
4.
4. Okay, so negative 1 give you 1 right here. 2 give you 4. 1, 2, 3, 4. Okay, right here. Negative 2 also give you 4. Okay, right here. Now I can make a curve. Oops, it's not going through. There you go. So you see that this function here, this square function, has a parabolic shape. That's why we call it parabolic curve, parabolic function. That's another name, another way of calling. Okay. So what will be the domain? If you look at from left to right.
Infinite.
0. Oh, sorry, never mind.
Infinite.
Infinite. Okay. What do you mean? What do you mean infinite? Like how you draw it into interval notation?
Minus infinite.
Negative infinity to.
Infinite.
Because look at that. All the value here is give you a point on the curve. And so you have to imagine. You got this curve over here, keep going up. Just keep going up. So that's why whenever point on the x-axis, you draw a vertical line, it's always hit the curve. Okay? You guys have to be able to imagine. When you do math, you have to imagine. So not a lot of things you can draw now. Not all of them. You have to imagine. Einstein said imagination is more important than knowledge. So imagination is very important. Okay? Range. How about range?
0.
0.
Yeah, because the bottom up we start with 0 and you keep going up. And do you think we include 0?
Yeah.
Yes. That is for the square function. And all of these functions you have to memorize. You must be able to graph all the basic one. You must memorize all the domain and range of this basic function. Okay, because if you don't, there's no way you can do transformation concept that we were going to learn on Wednesday. Okay, so make sure you have to memorize this.
I have a question.
Yeah.
So with the square function, there is no b, never?
No, B, because we talk about the basic right now. I don't want to include the B. That's why we do have the B and the C. Later on, we call the quadratic one.
Okay.
Okay, so the basic one is the one always go through the origin. They always go through the origin. We won't. Okay, so just right now, that's why I call it square function. You know, we don't call it like quadratic or anything. Alright, number 3, cubic function. Okay, the cubic function has look like this. Okay, that's for the table. Which point you want me to plug in?
0, 0.
0, 0, yeah.
1, 1.
Everyone has 0, 0, yeah.
1, 1.
1, 1.
2.
2, 8.
Minus 1.
Negative 1 give you?
Negative 1.
Negative 1 because negative 1 to the third power is still negative. Negative times negative give you negative. Negative 2 give you negative 8. I think we have enough. Okay, let's draw. Let's locate all the points here. 0, 0 here, 1, 1 here. Here, okay. 2, 8. Oops. 2, 3, 4, 5, 6, 7, 8. Okay, so negative 2 here. 1, 2, 3, 4, 5, 6, 7, 8. Another point here. So I'm going to connect all these 4 points. Alright, so it will be like this. Beautiful. I started learning this when I was in 6th grade. I don't know how you get, when do you guys first time learning this? In high school? I don't have high school here. Seventh grade, no, see? 7th grade. 7th grade, come on, man.
What class was that?
How many years?
Algebra 2.
Algebra
Well,
1.
I was like one step ahead though, so that was.
Oh.
It's like Algebra 2. Like,
Algebra 2, Algebra 1. Algebra 2 is
Sophomore
like,
year,
oh, is it,
algebra
Algebra 2 is must be 10 or 9, right? If you had.
One.
Yeah.
There was one.
Yeah. Uh-huh. But how many years? Come on.
No, I did my junior year.
And memorize it.
There's
You
not
have to
too many
memorize.
years
Algebra
of
geometry,
And-
Algebra 2
And at that time was, how many years ago when I learned? Oh my, 25 years ago we don't have a graphing calculator. No. I graph a lot, manually. Crazy. You know, we don't have graphing calculator. Right now you have like a lot of, you know, useful technology that's help you to do math. You know, back in the day, I don't have it. You have to do like manually everything. All right. How about the domain and range for this? Please. What is the domain? Looking from left to right. Left to right. Domain always look from left to right.
Infinity.
Minus,
Negative
negative infinity.
Uh-huh. And range will be
The same.
bottom up. Bottom up. Yep. That is a cubic function. Number 4. Radical function. Okay, so I'm going to split them into 2 cases. The first case, where we have even root, and the second case, where we have an odd root. So, on the case number 1, f of x equal to n root of x with n is even. Okay, for example, f of x equal to square root of x. Because they don't have invisible number 2 here, they can put it number 2, but it's invisible. There's a movie coming up. It's gonna hit the theater, Invisible Man. You know, you guys are gonna go watch it?
No.
Probably I don't watch it. I don't go to the theater. I just watch online from someone. They pirate the movie I watch.
This is on video.
Yeah, but 2-3 months later, they always have online. We don't need to spend. If you have a girlfriend, boyfriend, yes. you have to take her to the movie, yes. Okay, I don't do that anymore. Okay, so there's the invisible number 2 here, and it's the square root. So let's make the table. Let's see. Zero. Oh, you see that everything goes to 0. Oh my God. Okay, 0, 0. Yeah. What else?
1.
1 give you
1.
1. Okay.
4 gives you 2.
4 give you 2. And of course 9 give you something, right? 3, right? I don't think I have enough space for 9, so I just go ahead look at 3 point all these. 0, 0, 1, 1 right here. Okay. 2, 4. 4, 2, sorry. 1, 2, 3, 4. 2 up here. Okay. So I have a curve that looks like this. Alright. So let's talk about the domain range and we finish for today. Next time we keep going with we continue with the basic function. We still have still more, okay? So what will domain in this case?
0 infinity.
0 infinity, we want to include 0 because at 0 we still define. And the range will be?
0.
The 0 is thing defined. Yep. That's it, guys. Please go home, do homework. Okay? Watch the solution, guys. I post a beautiful video. Please watch it. Okay, I'm going to post the solution PDF.